loop forming statements in QB64. Do loop, while when, for next. Before starting with these statements, let us understand a few fundamental concepts about counters and accumulators. Counter and accumulator variables. Counters and accumulators are variables in a program serving a specific purpose. These variables should be well documented. Counter. A counter counts something. A counter variable has the purpose of storing the number of times that some condition occurs in the algorithm. A counter variable is a type of integer and is incremented every time when some specific condition occurs. The variable must be initialized to give a value which is usually 0. Suppose we need to count the number of students with marks greater than 90, we would take a variable count and its initial value is 0. Within the while loop, if the marks of a student is greater than 90, the counter variable is incremented by 1. Accumulator. An accumulator variable stores partial results of repeated additions to it. The value added is normally that of another variable. The initial value of an accumulator variable is normally set to 0. The algorithm can calculate the total marks by adding marks in each subject to the accumulator variable. Loop forming statements. Do loop statement. Do loop statements are used in programs to repeat code or return to the start of a procedure. Syntax: do, statement 1, statement 2, statement n, loop, until, while, condition. Explanation: the do statement denotes the beginning and the loop statement denotes the end of a do loop where the program jumps to the beginning of the loop if the optional condition is true. The code inside the loop will run at least once since the condition is specified at the end of the loop. A while condition continues the loop until the condition becomes false. An until condition continues the loop until the condition becomes true. If a loop has no exit condition, it will never stop. Control break can be used to stop an endless loop. Example: using loop while condition. Count is equal to 0. Do, print programming with QBasic. Count is equal to count plus 1. Loop while count is less than 10. This loop will be executed 10 times. As soon as condition becomes false, the loop ends. The same logic can be written as click Start to execute. Output screen. Example: using loop until condition. Count is equal to 0. Do, print programming with QBasic. Count is equal to count plus 1. Loop until count is equal to 10. As soon as condition becomes true, the loop ends. Click Start to execute. Output screen. Exit to statement. The exit to statement can be used to exit a do loop from inside of the loop. It is used to exit a do loop when a condition exists regardless of any loop conditions. Syntax: exit do. While when statement. With the while loop construct, the loop condition is tested first. If the condition is true, the operations in the repeat group are executed. This continues until the condition evaluates to false. The while when statement is used to repeat a block of statements while a condition is met. Syntax: while condition. Code. Statements: when. Explanation: the while statement denotes the beginning of the loop where it checks the condition. If the condition is true, statements are executed within the specified loop, otherwise it jumps to the statement next to the loop. The when statement denotes the end of a while loop from where the program jumps to the beginning of the loop again and checks the condition. Note: there is no exit while statement. The do loop statement allows more flexibility and can also use the while condition. Example 1. Using while when with counter. Count is equal to 0, while count is less than 10. Print, programming with QBasic, count is equal to count plus 1, when. Click Start to execute. Output screen. Explanation. The loop will print programming with QBasic 10 times and will increase the value of counter variable count by 1 each time. It stops printing when the value of count becomes 10. Example 2. Using while when with other conditions. Let count is equal to 0. Let $y is equal to y. While $y is equal to y or $y is equal to small y. Input, enter your name, $. Input, enter your age, age. Input, enter your nation's name, nation $. If age is greater than or equal to 18 and nation $ is equal to India, then count is equal to count plus 1. End if input want to continue $y. When. Print the number of voters are count. End. Click Start to execute. Output screen. Explanation. This program is counting the number of people who are eligible to vote. The loop will be executed till you want it to execute. The statements between the while and when are within the repeat group. Before reaching to the end of loop, we ask the user if he wants to continue with the process or stop. If the condition given in the beginning is not satisfied, then the control passes to the statement next to the when statement. For next statement. The for statement is used when we know how many times the task is to be performed. It creates a counter loop using specified number parameters. Syntax. For count variable is equal to start value to stop value, step value. Statement 1, statement 2, statement n, next, count variable. Explanation. The for statement initializes the counter variable with initial value and specifies the limit of the counter variable at which the loop should end. The statements between for and next will be repeated till the counter reaches to the final value. The statement next causes the next iteration of the loop, increases the value, and checks it with the final value. If the condition is satisfied, the loop continues. Along with start and stop value, you can also tell the step value with which the value of counter variable will increase or decrease. The step value is 1 if not specified. Infinite loop. If the variable's start value is more than its ending value, never use a negative step interval or the loop value will not decrease and the loop will never stop. Example 1. Generating natural numbers from 1 to 10. Ascending order. For I is equal to 1 to 10. Print I. Next, I. End. Click Start to execute. Output screen. In the for statement, we have taken a counter variable I that is initialized with 1. We specified the finite value as 10. No step value is given, so the value will increase by 1. First value printed will be 1, then it makes the value 2 and prints it. After every increment, it checks the final value. If the value is less than equal to 1, the loop continues. When the value becomes 11, it exceeds the final value, so the control exits the loop. Example 2. Generating natural numbers from 10 to 1, descending order. For I is equal to 10 to 1, step minus 1. Print I, next I, end. Click Start to execute. Output screen. In the above example, we have initialized the counter variable I with 10 and specified the final value as 1. Step value is given minus 1, so the value will decrease by 1 each time. First value printed will be 10, then it makes the value 9 and prints it. After every decrement, it checks the final value if the value is less than or equal to 1, and loop continues. When the value becomes 0, it goes out of the bound, so the control exits the loop. Example 3. Adding all even numbers from 10 to 0. For I is equal to 10 to 0 step minus 2. Print I, total is equal to total plus 1. Next I, print total of even numbers are total, print value of I after loop is I, end. Click Start to execute. Output screen. Explanation. The loop counts down from 10 to every even value below it. The counter keeps stepping down until the for statement is false and exits. Thus, the value of I is minus 2 after the loop is exited. Exit for statement. The exit for statement allows a condition other than the counter value to exit a for next loop. Nested loops. When a loop set of statements is enclosed within another loop, then it is said to be nested loop. The inner loop is executed the number of times specified by the outer loop. The nested loop is a loop within a loop, an inner loop within the body of an outer one. How this works is that the first pass of the outer loop triggers the inner loop, which executes to completion. Then the second pass of the outer loop triggers the inner loop again. This repeats until the outer loop finishes. Let us look at an example of nested loops at work. We have all seen web page counters that increases every time a new person visits to the web page. Your car's odometer works in a similar manner. This counter is made up of 8 nested for loops, each going from 0 to 9. The far right number iterates the fastest, visibly moving from 0 to 9 as you drive your car or increasing by 1 as people visit a website. A for loop which imitates the movement of the far right number is shown below. For num1 is equal to 0 to 9 step 1, print num1, next num1. The far right number, however, is not the only number that is moving. All of the other numbers are moving also, but they move slowly. For every 10 numbers that move in the column on the right, the adjacent column is incremented by 1. The two nested loops shown below may be used to imitate the movement of the two far right numbers of a web counter or an odometer. For num2 is equal to 0 to 9 step 1. For num1 is equal to 0 to 9 step 1. Print num2, num1. Next num1. Next num2. Click Start to execute. Output screen. The number of digits in the web page counter or the odometer determines the number of nested loops needed to imitate the process. When working with nested loops, the counter loop changes only after the inner loop is completely finished. Unconditional transfer of control. The go-to statement. The go-to statement jumps to a labeled line in the program unconditionally. Label can be a line number or some other name, label given to it. Syntax, go-to label. Example, 1 print, first line, go to ABC. 2 print, second line, go to 5. ABC, print, go back, go to 2. 5 end. Click Start to execute. Output screen. After it prints, first line it goes to the line label ABC where it prints go back, then it goes to the line number 2 and prints second line and goes to line number 5 and hits an end statement which ends the program.